Good morning everyone. My name is Ayush Kumar. Today I am here to solve my assignment regarding LP problem which is given by Dr. F. Sir. So let's start. So my question is, a company manufactures two products X and Y. The profit contribution of X and Y are rupees 3, rupees 4 respectively. The product X and Y require the service of four facilities. The capacity of four facilities A, B, C, D are limited. The available capacity in hour are 200, 150, 180 and the product X requires 5, 3, 5, 8 hours of facility A, B, C, D. Similarly, the requirement of product Y is 4, 5, 5, 4 hours respectively on A, B, C, D. Find the optimal product mix to maximize the profit using graphical method. So, first I have to make a table. So, the table is from here. First, I have to take a product. Product X, product Y. Now, facilities. Facility A, B, C and D. Facility A, B, C and D. Now the restrictions means limit. And here is profit from both the product. So here the profit is 3 rupees and 4 rupees. Product tax 3 rupees and 4 rupees. 3 rupees and 4 rupees. And the product X required the service of four facilities respectively A, B, C, D in product X was 5, 3, 5, 8. 5, 3, 5, 8. 5, 3, 5, 8. 5, 3, 5, 8. Now product Y required 4, 5, 5, 4. 4, 5, 5, 4. Now we have the certain limits, that's the availability of the service at facility A, B, C and D. So the limited hour of facility, limited hour are 200, 150, 180. 200, 150, 180. Let's perform it. 200, 150, 180. Now, so here is the table for better understanding. Now we have to decide the decision variable. So what will be the decision variable? Decision variable. Decision variable. So the decision will be let X and Y will be the unit number of unit number of product X and Y. So the let X and Y will be the unit number of product X and Y. So now we have to decide the objective function. Objective function. Since the profit on both the product are given, so we have to maximize the profit. So we can write is the since the profit on both the product is given, so we have to maximize the profit. Then we have to maximize the profit, so Z max will be 3x plus 4y, because x is the unit number of product of x and the y is the unit number of product y. So we have decided decision variable and we have find objective function. So now we have to find constants to plot graph using graphical method. In any method, like simplest method or any method, we will find same constant, same decision variable, objective function in a row. So Now constant. So the product X and product required, all the four facilities and the limited hour of availability of the four facilities are given. So we write here that product X and Y required all four facilities and limited availability is limited availability are 200, 150, 180. 200, 150, 100 and 80 for facility A, B, C, D respectively. So the product X and product Y require all the four facilities, and here is the given limited availability hour. So we have to first find for the 200, then 150, then 100, then 80 limited hour. So how the next step is given? Product X required, product X required 5 hour, and product X required 5 hour at facility A, and product X required 5 hour and product Y required 4 hour. At facility A. So the constant is given by given by 5x plus 4y less than equal to 200, because we have the restriction at 200. We have not to exceed the service facility, not to exceed the service at A for 200. So उससे ज़्यादा नहीं करना, तो constant is given by 5x plus 4y less than equal to 200. And now for the facility B, product X required another 3 hour and product Y required 5 hour. So all the constant is given as it is. So we write as the product So the constant is given 3x 5y. Now for product X and Y at facility C, required 5 and 5 hour, required 5 hour, 5 hour at facility C respectively. So the constant is given by 5x plus 5y less than equal to 100, because limit is 100. So the next constant and the last constant will be product 8 hour and 4 hour at facility D. So product X and Y required 8 hour and 4 hour at facility D respectively. So the constant is given by 8x plus 4y less than equal to 80 hour, because there is the restriction of 18 hour availability at facility D. So finally we have Z max or max Z equal to 3x plus 4y 3x plus 4y subject to first constant will be 5x plus 4y less than equal to 200 less than equal to 200. The next constant will be 3x plus 5y 3x plus 5y less than equal to 150. And the third constant will be 5x 5y less than equal to 100. And the last constant will be 8x plus 4y less than equal to 80. So finally we have maximum z objective function subject to constant 5x plus 4y, 3x plus 5y, 5x plus 5y, 8x plus 4y, this side the restriction or limited hour availability. So now we have to plot the graph for all these constants to maximize the profit for 3x plus 4y. So next step is the first constant will be, so we have to first plot the graph. So here is the graph, and now the first equation is 5x plus 4y. For this table will be so here is the first x and y, same 5x plus 4y less than equal to 200. So x will be 0, then x will be 0, then y will be 50, and y will be 0, then x is 40. So here is the first table, and now I have to open the second table. So for the next constant 3x plus 5y, if x is 0, then y will be 30. If y is 0, then x will be 50. For the next table, for this third constant 5x plus 5y less than equal to 100. So for x equal to 0, y will be 20, and y is 0, then x will be 20 from the third constant. And now the last constant 8x plus 4y. 8x plus 4y less than equal to 80. So if x is 0, then y will be 20. If y is 0, then x will be 10. So now we have to plot the graph with these regions, feasible region. So here is the range is between 50, 50, okay. Then this is 10, 20, 30, 40, 50, 60, and 70, 50. Now the same, the 10, 20, 30, 40, 50, 60, 70, 50, and this will be y and this will be x. So now we have to plot the graph with the feasible region. First equation for the first constant, that is x is equal to 0, then y will be 50, and the second y is 0 and 40. So the first line is plotted as x at 40 and y is 50. From this, from the first constant. For the same next constant, x will be 30, y will be 50. For the third constant, x and y both will be 20, 20. So, and the last constant, x at 10 and y is 20. Y 20 and x 10. So, here is the feasible region we can observe, that is the triangle with vertices 0, 0, 10, 0 and 0, 20. So the feasible region we found is the triangle with vertices vertices 0, 0, 0, 0, 0, 0, 10, 0, 0, 20. So now we have to evaluate the maximum profit. So evaluate the objective function. So the first will be, so the objective function is z max is equal to 3x plus 4y. As we seen at previously, 3x plus 4y will be maximum profit. So for 0, 0 at corner point, it is a mistake. So evaluate the profit at corner point. So at corner point 0, 0, Z max will be 0. At corner point 10, 0, Z max will be 30. And last corner point, at corner point 0, 20, Z max will be 80. So here we find the maximum profit at the corner point 0 and 20. So what is the final answer? What is the final answer? The final answer is produce 0 unit of product X and 20 unit of product Y. Then we find the maximum profit of 80 rupees. The final answer is we have to produce 0 unit of X of product X and 20 unit of product Y. So we found maximum profit of, or we get maximum profit of 80 rupees. So the final answer is we have to produce 0 unit of product X and 20 unit of product Y, 50 unit of 50. So we get maximum profit of 80 rupees. My question is solved now. Thank you. Thank you everyone.